Boys and girls, this is the last video of chapter 13, and it's all about hydrogen as an energy source. It begins on page 365 in the book. I will cover hydrogen and then that last section about our energy future. So I don't think this will be very long. You should be watching this on Wednesday. So Thursday, when you come into class, write down this one thing on a piece of paper because it's the most important part of the lecture. And that is, when we talk about hydrogen as an energy source, we're talking about a fuel cell. We're talking about a battery. The fuel cell is a battery. All right, so write that sentence down on a piece of paper and turn it in to me on Thursday, and that'll prove you watched this video. All right, I'm going to start with this diagram that I have of a hybrid vehicle that runs on hydrogen. And again, the first thing you need to remember when we talk about hydrogen as an energy source, we're talking about a battery system. But unlike the battery systems that you know of, you know how a battery works, like in a flashlight or the battery that's in your cell phone. It works because of a chemical reaction that happens in the cell between, for instance, with your cell phone, nickel and cadmium, and that moves electrons. The problem with that system, of course, is that nickel and cadmium wears out. It runs out of its ability to move electrons. So that's a closed container situation. For the hydrogen fuel cell, as long as you add hydrogen, you will always have electricity, and I'll show you how that works in a minute. These hydrogen fuel cell vehicles are going to be a hybrid. Whenever you see hybrid, what we mean is there's going to be an internal combustion engine included in the vehicle, and that is so that it will kick in when the electric stops producing electrons. The fuel cell, when it runs out of hydrogen, would run out of its ability to move electrons, and so then the internal combustion engine would kick in. Here's how a fuel cell works. First of all, you have to have a hydrogen source, and that is a problem. Right now, the most common way to make hydrogen gas is using natural gas. And you take the hydrogen out of the natural gas pool and use that hydrogen to react in the fuel cell. This is the fuel cell here. Obviously, that's problematic because natural gas is a non-renewable energy source. So we need to find another way to get our hydrogen. So far I said that's the cheapest way, but there's a more expensive way, and it does take energy to do this. It's called electrolysis. Write it down. Electrolysis is using electricity to separate the hydrogen atoms from a water molecule. Electrolysis is a reaction in which electricity is added and it separates the hydrogen atoms from the oxygen atom. So that's how we get our hydrogen source, but now we have to do something with it. You introduce the hydrogen into the fuel cell, and what happens, since hydrogen is just one proton and just one electron, we need to find a way to separate the electron from the hydrogen proton. And that happens when we pass the hydrogen gas across this membrane. This membrane does the separating. The proton is allowed to go through the membrane, but the electron is not. The electron is connected to a wire, and the electron goes along the wire and makes electricity, connects to a motor, and that turns the wheels of the car. The proton that's left over reacts with oxygen, and we get that oxygen just by having a scoop on the front of the car, and reacts with that oxygen that's just in the air and forms water vapor. And that's what we see here. There is exhaust, but the exhaust is in the form of water vapor, so it's 100% clean. There is a question about what happens with that water vapor. Are we, with the millions and millions of cars on the road, if they all ran on fuel cells, would we be unbalancing the water cycle, which is something that probably does need to be looked at further. All right, so using hydrogen to our advantage is something that we're looking at, but like the Who Killed the Electric Car video, we're a long ways away from being able to create hydrogen gas and make it transportable, and get it to every gas station in America the way we've so successfully done it when it comes to petroleum gasoline. But the fuel cell is in the car, and by the way, it's also possible that we could have fuel cells at our house. And the hydrogen man would come around and fill up your hydrogen tank like once a month, and you wouldn't need the grid. You would be making all your own electricity in a fuel cell along the side of your house. There are already entire office buildings in California that are running on fuel cells. So it is possible. The problem is the hydrogen gas has to be created. And I've told you the two ways that are done. Electrolysis is probably the wave of the future, but it takes a lot of electricity. And once again, think about it. If that electricity is coming from a coal-burning power plant, this hydrogen fuel cell is adding carbon emissions to the air in the form of creating the hydrogen gas. One other thing to note about the hydrogen fuel cell vehicle is that this electric car is more efficient than an internal combustion engine, so it will be able to get up and go. The hydrogen fuel cell vehicles that are out on the street now, mostly as demonstrations, they have get up and go. And as long as you have hydrogen gas stations everywhere, you'll be able to go, virtually forever. You just keep filling up your tank. So there's the big negative to hydrogen right there. It's the fact that we have to make the hydrogen gas. And we have to find a way to make it without spending more fossil fuel than we would be saving. We have to worry about the safety of the hydrogen tanks here. These hydrogen fuel cells, these hydrogen tanks, hydrogen gas is highly combustible, so we've got to come up with a safe way to store that hydrogen, so if every time a car gets rear-ended, they don't have a big explosion when the accident occurs. Lots of pluses, but a few minuses. And of course, as that guy said in the movie, we're probably a long ways away from taking advantage of this hydrogen as a source to move our cars. But having said that, the more scientific effort that's involved, the more experimentation that happens, the more research conducted, the quicker we can get there. And there are places in the United States and around the world that are using hydrogen as an energy source, in this case for a bus, a public transportation vehicle. That's hydrogen. You've got this table in your book, and it is the ultimate comparison when it comes to all of the different renewable energy sources. We have covered them all: biofuels, biomass, hydroelectric, tidal energy, photovoltaic cells, solar water heating and solar cookers, geothermal, wind, and we just got done with hydrogen. Wow, you need to have this table sort of like memorized in your heads. You need to know pros and cons of every one of these. This diagram is on page 368, and if you're going to study anything for the big exam that's on Friday, you should study this table and the one just like it that's in chapter 12 about the non-renewables. All right, what about our energy future? Okay. Most electrical engineers believe that this big giant grid with these large power plants is a very inefficient system. And indeed, we see much of our energy, about 10% of the electricity that's generated at the power plant is lost. It's lost as heat. I mean, the wires, the electrical wires that go to your house are warm. That's why in the wintertime you see birds sitting on the electrical wires. They're generating heat. That's wasted energy. One solution to losing all of this and trying to control where electricity comes into your house is something called the smart grid. And the smart grid idea is that using computer technology, we can self-regulate the electricity and how it gets distributed across the United States. And that includes the electricity demands, for instance, at your house. One of the problems we have with the grid system that we have today is that people use electricity in very predictable times. For instance, in the summertime, in the heat of the day, everybody's air conditioners are trying to cool their house. There's a tremendous strain on the entire grid when that happens. In fact, places like New York City, when they have a heat wave, they are very concerned about drawing too much electricity out of the grid because everybody's got their air conditioners on. So the idea is to form a smart grid and use smart appliances that are plugged into the smart grid, and all of the right electricity gets used at the right time. An example of that would be the smart appliances here. You might want to run your dishwasher in the middle of the day when everybody's using their electricity, but a smart appliance would keep you from doing that. The smart appliance would draw the electricity in the middle of the night in an off-peak situation. Good idea. And in fact, you can implement that in your home right now. You should not run your dishwasher in the middle of the day. The best time to run your dishwasher is in the middle of the night. And indeed, many of the smart appliances you buy today, I have a smart dishwasher because I just had to buy a new one last year, so I went with the smart appliance. You can set a timer, so you can make it click on in the middle of the night. And they're so quiet these days, you don't even know it's on. The other thing about the smart grid is a more decentralized energy system. Even if we don't have large power plants, the idea is to kind of decrease these large ones and have more smaller scale electricity parks all over the place. And these decentralized energy parks would use a combination of renewable and non-renewable energy. If you want to think further into the future, do what I was just saying. Fuel cells. Everybody will have their own hydrogen fuel cell at the side of their house, and you won't even need to be connected to the grid. You'll make your own electricity. So all of these are ideas that are coming in the future. Remember, the question that always gets asked, what's the best way for us to address our energy needs? The best answer is always use less in the first place. Use less in the first place. So that is conservation, energy conservation. The next best thing is improve energy efficiency. And you can see these different things that can be done. It's going to take government action probably. It's going to take something like the California mandate to force car manufacturers to come up with these vehicles. And one way that government can change consumer behavior is to provide tax breaks or tax credits if you buy a hydrogen fuel car. Provide tax credits to power plants that take sustainable energy strategies into mind. Reward utilities that reduce demand if they can do that by encouraging their customers to do better. More renewable energy, we need to increase our renewable energy. We need to use hydroelectric more. What did we have on that pie chart at the beginning of chapter 12? Only about 7% of our energy comes from renewables. We need to increase that to 20 or maybe even 40% in the future. And we can provide subsidies to make that happen. Already, you can get a subsidy if you add a solar panel on your roof. That helps defray the cost because solar panels are expensive. So the government will pay you back some of the money that you spend to put that solar panel on there. And of course your electric bill will be lower. The best estimates we have right now are if you were to add solar panels on your roof, it would pay for itself in about 7 years. That's a hard sell because most people, especially in your generation, we estimate will not be living in their same house for 7 years. So you have this initial big dollar upfront expenditure, and then you have to worry about whether or not you're going to stay in the house. So you're not there long enough to realize the savings on the expenditure that you made. If anybody wants to talk about the future of energy, we can certainly do that. Here are some statistics about what we're doing here in the United States when it comes to energy efficiency. 81% of us are using energy efficient light bulbs now. You know, the price of those has come way down since they were introduced at like $7 or $8 a bulb. They've decreased in expense and they last longer, so people are sort of sold on the idea of using these energy efficient light bulbs. Buy Energy Star appliances. 44% of Americans report that they have some sort of Energy Star appliance in their home, and we need to increase that. Remember, Energy Star appliances use less electricity, so you save. You do pay a little bit more, but not like when they first came out. They were almost double. You can do better by just making your house more airtight so that you don't lose the cool air in the summertime that you're using electricity to make, and you're not losing the warm air in the winter that you're using electricity to make. In both cases, make your house a little bit more airtight. If you can see a gap outside, if you can look at your door and see a little bit of light coming in, then it's not nice and solid and caulked in the way it should be. Double pane windows, efficient windows and doors. 29% of Americans report that they do that. All the windows in my house, for instance, are double paned windows. Most of you probably have double paned windows because that's sort of the standard, and a lot of us live in newer homes. Since like the 90s, people are using double paned windows. But really, the super insulated window that you would use for passive solar energy is triple paned. 23% of Americans report they've upgraded their heating and cooling systems. 21% have reported they bought a high efficiency water heater. And of course, not very many people have gone to the extreme of installing their own renewable energy system like a solar panel or a wind turbine. But the people that have are enjoying big savings on their electric bill. So that's how we're conserving here in the U.S. All of those are good ideas. And I'll tell you what, on an AP or ACE exam, if they ask what can be done for energy efficiency, these are the things. All right, that is it for chapter 13. I hope you enjoyed it. It's a long chapter. It's full of great information. We'll have our exam on Friday, and then we'll launch into the next two really big chapters Water pollution is chapter 14, and that's a long one. And then air pollution is chapter 15. Those are, again, quite the heart of the entire course. Now that we've talked about how we produce our energy by non-renewable and renewable means, it's time to get into the details of pollution and understand the science behind what's happening with water and air pollution. Then chapter 16 is all about waste, how we deal with our waste in this country and indeed around the world. Okay. Hope you enjoyed it. It is Super Bowl Sunday, and I'm getting ready to sit down and watch the game. So, hope you enjoy it too. See you later.